Alrighty, sweet. So today we're going to be talking about two concepts that are very useful in Python, primarily. You can do it in other languages too, but we're just going to be focusing on Python today. And those are called currying and decorators. So what currying lets you do, which is the first thing we're going to talk about, is it lets you write a function that you can set constraints on when you're using. So for example, you can create a very general generic function, but let's say that there's specific use cases for that function that you know from before. Like, well, we'll go through an example, which you see on the screen, and there's another example in the curriculum, but I'm trying to see if I can come up with another one. Trying to think of something that's not food related because there's a food thing on the screen already. Okay, here, let's do this. Let's say, that you have a factory and you need to create a function for this factory that talks about or that shows like costs and outputs and stuff like that. So, you can do that like generically. You have like a bunch of your inputs, you have all of their associated costs and like the outputs, right? Like this function is going to be the same. It's going to be like, very general. But let's say you have three clients, right? And you have one client that only manufactures tires, one client that only manufactures microwaves, and one client that manufactures like soap. Now, the system that you're going to use for, calculating the output of those factories, it's going to be the exact same thing for all three of those clients. Except, like for tires, say they might have like an additional few inputs, or for soap, it might have like a longer time frame or something like that. And the function itself is the same. So how can we create a general function that we can still apply to specific use cases, but not have it look super cumbersome? And that is what we're going to do that's basically what we can use currying for. So a simple example is on the screen. So, let's say that you're working for a guy called Bob. Bob owns a candy store. He has a lot of different types of candy and a lot of each type of candy. And he wants you to make a really simple system that like anyone can use to keep track of his candy inventory. So he's got a list or a dictionary in Python, because apparently Bob knows how to make dictionaries in Python. And this has the types of candy and the amount of each type of candy. And apologies, got a really dry throat today. So people usually only buy one type of candy from Bob at a time, but they can buy as much of that one type of candy as they want. So, like if I'm going to Bob's candy store, I can say like, hey, I want Kit Kats and I want 15 of them. Or, hey, I want like Chex Mix and I want 300 boxes. That's something like that. So our goal is to make a function that takes in the candy inventory dictionary, the candy type to be purchased, and how much he's going to buy. And this function, really simply, it should just return, the modified candy inventory directory. Okay, so let's try solving this. Like this shouldn't be a super bad problem to solve, only a couple lines, but I want to run through the whole problem solving process with you guys. So what's the first thing that I want to do when I see a programming problem like this?
Write pseudocode.
Okay, perfect. So let me break that up. Pseudocode. Okay, so in our pseudocode, before we do our pseudocode, though, we have one thing that personally I always like to do before I even start thinking how I'm going to tackle. Any ideas for what that's going to be?
Define the inputs and outputs.
Exactly. Thank you. So we need to have a list of our inputs, and then we need our outputs. So, what are the inputs to our function?
Type of candy and how much quantity.
All right, type of candy. We have quantity of candy. And then we also have that candy dictionary. Candy amount dictionary. And then what are we outputting?
A list, the dictionary.
Yep. So or we'll just say updated candy amount dictionary after the candy was bought. Okay, cool. So we've got our inputs, we got our outputs. So let's give each of these inputs and outputs a variable name because that helps to keep things concise. So let's literally call this candy dict. We can call this candy type, and we can say that what type. This will probably be a string, and quantity of candy is going to be like candy amount, and this will let it be an integer. And then this is again going to be a dictionary. Alrighty, so pseudocode. I mean, we have these three things. We need to do stuff with them to get the output out. How do I do that? Any ideas?
No, you just start with like high level steps of what you want to do. So like at least how I've been doing it is I would go like step one, and then so then I'd like get the find the candy and the amount, or I'm sorry, find like iterate through the dictionary, finding the candy that the person, assuming, is this programming assuming that they already inputted the candy, or do we have to ask them for the candy?
So the function is going to take in three inputs, right? It's going to take in the dictionary that Bob gives you. It's going to take in the type of candy and the amount of candy that like the person wants to buy.
Okay, yeah. So go through the dictionary and find what candy they got. That would be what my first step would be.
Okay, cool. Anyone want to share step two?
Look at the
For
amount they want
step
to buy
two,
and
you
make,
can verify the amount of candy and make
Okay.
sure that there's enough for them to buy what they want.
All right. Make sure there's enough for them to buy. All right. So let's do a 2A. If there is not enough for them to buy, what do we want to do?
tell them to choose less.
Yeah, okay. So we could like print a message saying you can't do that and return the original dictionary. But let's say that there is enough. So if there is enough for them to buy, what happens?
Remove that number from the dictionary.
All right, cool. So subtract amount bought from dictionary entry and return the new dictionary. Okay, cool. That pseudocode looks pretty solid to me. What do the rest of y'all think? Is this the way that you'd probably do it? Or anybody want to share a different way that they might tackle this before we start actually coding it? All right, cool. So in that case, let's start coding. So, let's define this as a function. We'll say like define candy store transactions. Let's put in our inputs. We got candy dict, we have candy type and candy amount. And I'm just going to put in like a little return statement there. Okay. How do I fill this in? Let me see if I can find someone who I haven't heard from yet. Jordan Anderson. what would you do to start turning our pseudocode into actual code? First, let's say step one. Oh, I don't think I can hear you. Can anyone else hear you?
No, sorry. I have two mutes.
Okay.
I would define the dictionary and start putting
Yep.
the inputs for it.
Yep, so the dictionary is already in the input.
Okay. Go through so then we're gonna go through the dictionary to find what candy they want. So do we need to, so we'd do a user input, correct?
So that, well, so let's say the user inputs candy type in this function. So this would be candy type. And then the dictionary is going to be candy. So we're already given like all three inputs.
Okay. So then we're gonna loop through the dictionary and compare to see if we have enough of the candy type that they want.
Okay. So let's back up, right? So the first, I mean, I think you've got the right intuition, but the first thing we need to do is go through the dictionary to find like the specific entry for whatever candy they want, right? So in Python, like now we're going from the English pseudocode to the Python code. How can we find the entry in a dictionary? And remember, the dictionary is key value pairs. How can we find the entry in the dictionary with the relevant candy type?
So would we go for candy in candy dict dot values, or actually keys, because we're looking for the keys, right?
Mhm.
And then and then we say if candy equals, or yeah, double equals candy type. Then we're gonna update. Oh, I feel like we should actually pass that somewhere.
So I'll give you a hint. So the part that goes on line 30, like the part that's saying that we're going to find, like, okay, here, let me update the pseudocode actually, just to make it a little clearer. So we want to find the amount of candy for the relevant candy type, right? So do we need to necessarily loop through the whole dictionary to do that, or is there an easier way to do it?
There's probably an easier way, but I'd probably just loop through it.
Okay. Well, here, let's do the loop through first, and then we'll do the easier way after. So now that we're looping through the dictionary, now we're checking like all of the candy pairs, right? So here, let's make like a sample candy dict. So like say sample dict is going to be like Kit Kat, and there's like 100, and then like Twix is like 300, and then like cookies, which are not candy, is like 14. And let's say that I want to buy I want 3 cookies. So using this looping strategy, cookies is in candy. So where do I go from here?
So
just in terms of finding the amount of cookies currently in the dictionary.
So then you just print candy dict dot values.
So dot values would give you all of the values in the dictionary. Right?
Oh, items. Because we're
No.
looking for the type or the amount, correct?
But we're only looking for we're looking for how many cookies there are specifically. So I just want to get this 14 number. So how can I do that?
Is it dot cookies? I'm going to be really mad if it's dot cookies.
Yeah. Or, I mean, we can do it, even more simply. We can just do candy dict candy, right? So here, let's just do like a print, and then here, let's just try this out, right? So yeah, let's let's run candy door transaction. I'm gonna run with sample dict. I want cookies and I want 3 of them. So let's just make sure that this works first off. And if it does, then I'll show you the simpler way. If it doesn't, we have a big problem. Oh, because built-in function or method is not iterable. So anybody have an idea why this error is getting thrown? I'll give you a hint. It's because there's a really small syntax error.
We need to add the oh, where is
Parentheses.
it? Yes, those things. Yeah.
Yeah. So remember that candies is, or keys is a method for a dictionary, right? It's not something embedded with it. So we have to run that as a method. And there we go. So, it's going through the keys. It's saying if candy is candy type, which is cookies, to print out, candy dict at candy is cookie. So we go here and we print out 14 and it prints 14. Awesome. So Jordan, thank you for helping us get to this point. So that knocks out part 1 of our pseudocode. But there might be an easier way to do this. Without actually looping through the dictionary like this. There is a bit of a simpler way to do it. That actually we can do it in one line. And it uses something that we already have somewhere in here. Let's see. Anyone have any ideas?
Just use an if statement. If candy type in candy dict.
Okay, so you're saying if candy type in candy dict, like that?
Yeah, maybe I'm wrong. I have no idea.
Let's try it. So here, let's now let me comment out the loop here. And then, we obviously don't have candy anymore. So we can just do candy type. And here, let's see what happens. Yeah, looks like that worked. And I can change this to something else. And it doesn't work. Okay, sweet. And at the same time, this also knocks off one of our edge cases. So Vincent, thank you for that suggestion. So the point is we didn't actually need to loop through, every single entry in the dictionary. The benefit of dictionaries is if it exists as a key, we can just go right to it. So like if cookies is a key, we can do candy dict cookies, Twix, candy dict Twix. And it just makes it a whole lot easier. And I mean, you can cut a couple lines that way, which is good. So, okay, so we've got part 1 of our pseudocode done. Thank you to Jordan and Vincent for helping to facilitate that. All right, so let's change this now. So I'm just going to, well, we can refactor the code later. So I'll just say refactor for simplicity. And let me just note down here order of ifs. Okay. So, let's say that our candy type has been found, right? So, let's see, who do I want to choose for the next part? Matt Hemsworth. How would you start doing bullet point 2? So verify the amount of candy and check that there is enough for them to buy.
I would make another if statement, checking to see if candy dict candy type is greater than candy type. Wait, candy amount, right?
Okay. All right. And then, let's say that it is enough. So then let's see, who can I choose next? I'm Dylan. How would you do this part? So subtract the amount bought and return the new dictionary.
Could we say candy amount minus, or will you do candy dictionary, candy type minus candy amount?
Okay. So, and then how do we, but this is just an expression, right? How do I set that in the dictionary?
We would do, could you just do candy dict candy type equals and then that, or could you do equals minus? Like, could you,
Minus equals.
or yeah, my bad.
Yeah,
So
all
that would
good.
work.
Yeah,
Okay.
that should work. And then now that we've done that, we just need to return candy dict. That should be pretty good. And let's just do the else for this because it's an if. Every if should have an else, right? Katya, any ideas for how we can do the if there is not enough for them to buy?
In that case, I think you already wrote else, is that right?
Mhm.
So there we could have I'm thinking either a print that states not enough inventory or amount or something along those lines, or return and having that same string kind of depends on how exactly we want to approach it.
Yep, yeah, we can just do an else. Nice and easy. Print there's not enough candy, and then return candy dict. And we should also out here, we should probably also have an else that just says like print, candy not found, and then return the original candy dictionary. But okay, cool. So let's see if this, let's see if this actually works. So ideally, what this should do, right, before I run any function, I always like to run through it in my head to make sure everything looks good. So we have our sample dictionary with, our 3 categories. Oh, nope, I didn't want to Control Z, I want to paste. So we've got Kit Kat, Twix, and cookies, and we're going to take this and say we want to buy 3 cookies. So if cookies is in candy dict, cookies, yep, that's right there. So that's good. We'll print candy dict candy type, so we should print 14. If candy dict candy type is bigger than 3, yeah, it should be. So then we get 14 minus 3 is 11, and we return the new dictionary with 14 being replaced by 11. So let's see what happens if we actually do this. All right, so it prints out the 14, and look at that. We have 11 cookies left. So that's good. Now, let's say I change this 3 to a 30. You can't buy 30 cookies if there's only 14 in stock. So if we run that, we see here it says not enough candy, which is perfect. So here we can take out that print statement. And let's say that we're going to make cookies instead of cookies, which does not exist in our dictionary. So that should print candy not found and return candy dictionary. And perfect, it does. So, hey, it looks like our function works. Anybody have questions about why it works or what we did to get here before we move on to the next part? Nope. Okay, great. So we have a functioning function. But let's be honest, this function looks just slightly ugly in a few ways. So what we're going to do now is, now that I've written the function, the first thing I want to do is refactor it to make it simpler. So whenever you've written a function in general, it's always a good idea to take like a short pause, come back to it and be like, okay, a bunch of syntax or stuff in this can be simplified, made better, shorter, whatnot. So let's do that here. So usually it's not a bad idea to put your edge cases before everything else. So for example, saying that the candy isn't found, we can do that really, really easily. All we need to do is, let's refactor this function. Let's just swap the if and else statements. So I'll move this down to after. We'll keep that else up there. But obviously we can't have an else up here because there's no if. So we'll just change this to the if. We'll change this to the else. Move that. And then we're just going to change this to be not in candy dict. again, it's just good practice to have your edge cases come first. So I'll have edge case, candy does not exist. Now the else is going to tell you, okay, well, the candy does exist. So we can do the exact same thing. But also, yeah, here, let's keep the else. So let's, flip it on its head one more. Actually, this is probably okay. Now there's one thing that I really don't like in code. And if it's one thing that I don't like is having repeated expressions. We refer to candy dict, candy type like multiple times. Another thing that we could do here is like add a print statement and say, total number of, and then candy type, and then we could add in like a plus and then say it's like equal to, and then like a string of candy dict, candy, where's the key type? And this would just print out, hey, the total number went from 14 to 11. Now we've reused candy dict, candy type like 3 times. Instead of like continuously writing candy dict, open bracket, candy type, close bracket, that just looks bad. Why don't we set this equal to some sort of variable? So we could just say like current candy amount. And then now we can simplify things a lot more. Okay, that just completely glitched out. But we can replace all of these instances of candy dict, candy type with current candy amount. Number one, that helps to make our code a little bit more readable. Somebody might not know what candy dict, candy type is. And if they see it 50 times in code, it's like, it's got to be important, but I don't really know what this is. This is also where adding comments comes in handy, but to save on time and also because I'm going to talk about why currying is really important soon. We're not adding too many comments, but yeah, I should probably do that actually. So we can say get current amount of candy and dict. Here we have check that enough candy exists to be bought. If so, then update dictionary, and then we return it, and it's pretty simple. So again, this is just a minimal amount of refactoring. Oh, actually, I did just realize one thing. We cannot change this guy because that just changes the variable. So there we go. That should do it. And let's just double check this works one more time. Okay, that's fine. We'll change this to cookies and we'll make it 3, just like before. And should also change this probably to that. And let's hit run. Perfect. Okay, great. So the code is now refactored and it works. So I know I went through the refactoring a little bit quickly. If anybody has questions about it, feel free to ask, because refactoring is an important part of programming. But I don't want to spend too much time on that because I want to move on to these edge cases. So anybody have any questions first off, before we move on to talking about the next part of this little puzzle? Okay, cool. So let's go back to our candy store transaction, right? So our function right now allows you to buy as much as you want of any candy type that exists. But, let's say that Bob's candies are, Bob puts a sign outside his door and he's like, I'm a small candy store. People love my candy, but I don't have enough to give everybody like 1,000 pieces of candy. 1 candy per person. So how can we do that? How can I say that 99% of the time, people will only buy 1 piece of candy from Bob? Any ideas? There's 2 ways of doing it in Python. So the first way is really easy. We can set something called a default value. inside of your function definition. So what a default value is it basically says, okay, the user doesn't necessarily have to provide this data. So like candy amount, they don't have to provide it. If they don't put it in if they don't write candy amount, then it'll just assume it's 1. But if they do write candy amount and they say candy amount is 15, then we have to change it. So, let's go down here and just see how that works. So if I completely delete that comma 3, right? That 3 was associated with candy amount before. But now I'm only giving 2 inputs. I'm giving it candy dict and candy type. And then the last thing is here, candy amount, I'm setting it to 1 arbitrarily. If I run that, we should get cookies goes down to 13. And we see that indeed it does. But let's say again, this guy's not just buying 1 cookie, he's buying 5 cookies. But in here, doesn't it say candy amount equals 1 by default? Yes, but the input that you hand write into the function, or into the input to the function, will override the default. So the 5 takes precedence over that 1 here. And we see here, it's reflected by saying the total number of cookies is 14 minus 5, which is 9, instead of 14 minus 1, which is 13. Does that make sense? Any questions about how defaults work for functions in Python? Okay, so that's one way that we can do this. The second way is going to be using curry. And this is where things get marginally more complicated. So we see that this strategy works really well if customers only buy 1 piece of candy from Bomb, right? Because it's always going to be either 1 or some other number. But what if customers can only buy 1 piece, like laying out on the table, or a box of 5 or a box of 10? We do not have a way to provide 3 different defaults in Python. It's 1 default value for every single variable. And again, you could just say, oh, well, every single time that I write this function, why don't we just say 5 or say 10 or say 1? Number 1, it just looks ugly. Number 2, you might forget. So it's sometimes if you have 1 function, like the function for the transaction is going to look basically the same for any of these amounts. But, let's say because 1, 5, and 10 pieces are the most common, you might want to have a separate function for when a customer buys 1 piece, for when a customer buys 5 pieces, and for when a customer buys 10 pieces. And that is where currying and decorators, well, more specifically, that's where currying comes in handy. So what currying does is it allows you to essentially nest a function within a function. So let's see, I'm trying to think about what a easy way is to do this for this example. Here, let's copy candy store transaction. Let's copy it down here. And then let's call this candy store transaction curried. And we'll keep everything else the same. Except there's a couple of things that we're going to change. So the first thing that we want to change is the stuff inside of, let's see. Here, let's take out the, actually, we can just do it here. So we have our candy store transaction. Now the base inside part of the transaction is going to stay the same, but that is only depending on candy amount. So, right, because again, the only thing that's really changing, the only variable we could say is whether they're buying 1 piece, 5 pieces, or 10 pieces. So let's just make a new function within our candy store. And we can just call that define like a generic transaction. And we'll put colon there. And let's go down here. And let's just make sure there's no errors anywhere. Beautiful. And then the last thing we're going to do is we're going to return, what did I call this? Generic transaction? Return generic transaction. Okay. So what on earth did I just do? So let's compare the differences between these two functions. So we have our new function down here and the old function up here. So the main difference really between the curried function and the old original function is we now have nested one function inside of another. While in the previous one, we just had one function for the whole thing. So let's break down what we're doing here. So inside of our candy store transaction curried, we are defining a new function called generic transaction. And we are copying the exact same code inside of it, just for simplicity. Now you might say, okay, well, if we're just copying the exact same code, what's the benefit in creating two functions inside of each other? Whereas it's just like looks better and it's easier to do it with one. And you'd be right. It does look a whole lot better to just have one function instead of having a function within a function. But this is where the constraints of our problem come in handy. So in the problem statement, again, we said, what if customers buy 1, 5, or 10 pieces? With this setup, we can custom define a function that is only for 1 piece, 5 pieces, or 10 pieces. So let's see how that works. So forget the decorators for now. Using this new function, let's say that I want to only do something that buys 5 pieces. So we can say like transaction like 5, or we can say like buy 5 pieces. And what did I call this? This was candy store transaction curried. And we see here there's only one input, which is candy amount. That candy amount's going to be 5. Now, let's say that, I want to buy 5 pieces from, let's see, what's candy dictionary? It's going to be sample dict. And we're going to buy 5 Kit Kats. So functionally, this statement is the exact identical to candy store transaction, sample dict, Kit Kat 5. These two are the exact same thing. Like functionally, they do the same thing, and I can prove that in just a second. So we'll say print. And let's just run it. And where's the run button at? Here it is. Yeah, I mean, we see here like this one. This buy 5 pieces substitutes 5 or takes away 5 from the 100. The next candy store transaction run, that one also takes 5 away. Okay, so let's say that you have 10 people who have now bought 5 pieces of this candy, and you need to calculate the inventory for it. Instead of running the original function, which, let's be honest, this is really long and looks a little bit ugly, we can just run buy 5 pieces 20 times. Simple as that. And that way, let's say, that way you also avoid, a typo. So let's say, instead of 5 here, once you mess up and type in like 10, well, you just had 5 additional pieces of your inventory go away. Versus, by using this buy 5 pieces function, you've got the same result every single time. Also, we can use this for, again, same exact thing. We can do buy 1, buy 5, or buy 10, right? So we can say a buy 1 piece. You're going to buy 1 thing. You got 5, and you have 10. And, you can hypothetically think about, if you're like doing something at like a cash register, or you're setting up code for like a website interface, and you have a people can press a button and it's either a 1, a 5, a 10, or custom. Well, this one goes for the 1-piece button, 5-piece button, 10-piece button. And this is identical again to doing this whole complicated thing, but instead we can say 10 or 1 or something like that. So that is basically the main use case of currying. It's where you have a general function that in most of the time only has a couple of use cases. And it lets you create a specific function for each of those use cases. That's really all it does. Any questions about what currying is before we talk about decorators or why it's useful? Did the example clear things up at all?
Could you show what the function definition looks like again when it's curried?
Sure. So let's go up to compare these two one more time. So when it's regular, we put in all of the stuff on one line. All of the variables in the same function definition. For when you're currying functions, you're defining a function within a function. So the reason that, let's say the big parent function, candy store transaction curried, only takes in candy amount. Why does it do that? Because if we go up to our problem statement, that's the variable that determines, which function we're going to use. If you're going to buy 1 piece, we will custom write a function that is only for buying 1 piece. If you're buying 5 pieces, we make a function that's specifically for buying 5, etc. So when you choose which definition or which variables you want to put in the parent function when you're currying, that's all depending on your problem statement here, like what thing is changing. Then inside of that parent function, we have you could call it a child function. I'm not aware if there's a better name, but I'll say that for now. You can call the second function using the other parameters. So again, the main advantage is you can create a separate function for any of those use cases, which, if you're going to call it like 100 times in your code, it's probably just easiest to custom write a function for that instead of writing out the whole string every single time. That's really all currying is good for. Does that help clear things up a little bit?
Thank you. Yes.
Anyone else have questions about currying before we talk about decorators? Okay, so why don't we take, say, a 5-minute break before we do decorators? Because it's a little bit weirder. And then we'll come back at 25 past the hour and talk about those.